Ladies and gentlemen, boys and girls, children of all ages.
Yeah, just get to watch the camera.
Now, as we have begun our unit on fractions, barely, and some of you were like, it's a fraction. I've never seen a fraction before. And like my second grade daughter there at the time. Anyway, so we got to go back and we're going to learn some stuff. Just remind us of some stuff that we should know. But we got to do that quickly. Now I'm going to ask you this, and I just want by a show of hands. Okay, on Friday I sent home several things on fractions that you could do on the website, on the interweb. Yes. And I want to know, by a show of hands, how many of you got on the interweb and looked at any of those. Okay, good. Thousands of you did. Awesome. If you are not one of the thousands that did, I need you to be one of the thousands that did, which means if you're not one of the thousands that did, I need you to be one of the thousands that do. Okay? I'm not just sending them home just, hey, what's up? I'm going to send these home for the fun of it. So, ask your parents about the email that was sent last Friday. All right, so Maya. I can't hear Maya.
My mom showed me her email. You just have to say the whole word out that you said last week. Say one time last week.
Oh, did I send the wrong one?
Yeah.
Okay.
Must have.
I put extra copies on this, so I apologize. All right, so we're going to talk about, first of all, less than or greater than a half. So I'm going to put a fraction up there. You're going to have to determine whether it's less than a half or greater than a half. And then I'm going to call on somebody to explain how they know whether it's less than a half or greater than a half. Kind of important, especially with that problem we did about the people swimming with the Santa suits on. Swimming with Santa suits, you kind of had to use your knowledge a little bit. You're going to have to use your knowledge a little bit. So our first fraction that we're going to use, and we're going to look at, is 3/8. So I want you to think about it. I don't want you to yell anything out. Just want you to use your brain. All right. Hey, Jabril, less than or greater than half? How do you know?
Because it's not 8/8.
Okay, because it's not 8/8. Good. Natalie.
When the number's bigger, the pieces are smaller, and half of the 8 is 4.
Okay. So when the denominator is bigger, the pieces get smaller, and you can tell by looking at this one over here. And you said half of 8 was,
4.
and what does that mean exactly? I mean, I know half of 8 is 4, but how does that help us in this particular manner? Okay, so you're telling me the numerator has to be what?
4 to be in half.
Okay, and on any other fraction. So if I gave you the denominator 12, what would the numerator have to be to make it a half? Okay, how are you coming up with this?
Because half of 12 is 6.
Okay, so if your numerator is half of your denominator, then your fraction is going to equal exactly a half. If it's less, like it's less than half of my denominator, it's going to be less than a half, which also means, Lillian, if my numerator is more than half of my denominator, that means the fraction is going to be more than 1/2. Look at that. I mean, look at that. She probably did not know that until she walked into my classroom today. It's absolutely amazing. She's brilliant. I'm just saying. Hunter.
What if you have a number that doesn't have a half, like it's off?
Like it's odd. Well, that reminds me of our next number. Let's look at this fraction. 3/5. So Hunter, if you had to look at that, we had to use some thinking. Less than or greater than a half? Okay, rounding doesn't matter here. If I said, Hunter, you have $5, I'm going to run over there, kick you in the shin, take that $5 from you, and I'm going to give half to Caroline. How much money does Caroline get? Not 2, not 3. She's going to get exactly half of $5. What's exactly half of $5? Shh. Hunter is begging to tell me this. $2.50. So, or it could be written as 2.5.
Yes.
So 2.5 is half of 5. So is 3 greater than or less than that? And 2.5. It's greater than, which makes this fraction greater than a half. Greater than a half. See? Does that help? Make sense? Make pennies? Luna?
It's like when you have like, so you have like. So
You've said like 3 times in that sentence. Go ahead. But I say so all the time when I'm teaching, so go ahead. It's like
I say I too. So.
I too, that doesn't even make any sense.
R2 makes so much sense.
Sounds like a movie about robots or something weird.
R2D2.
So if you use dollars for that example, you can to like split it in half. You can use pennies, like or quarters.
So place value.
Yeah. Like you have.
So if I wanted to find, and when you find half of something, and I'm going way off track here, but that's fine. When you find half of something, you're dividing it by 2, right? You're splitting it into 2 equal parts. If you find half of something, you're splitting it into 2 equal parts. Okay? So, and splitting it into 2 equal parts is just like dividing by 2. Okay? $5, we can't change it, right? We can't change it. But, as my friend Hunter said,
It's gonna have to be a remainder.
no, it's not going to have to be a remainder. Because $5 is the same as saying 5.
Yeah.
Remember, we can put the decimal point and the 2 zeros behind it. Remember that? You remember?
Yeah.
Remember when we did that?
Yeah.
Remember? Okay. Okay. So,
I was just saying.
you're going to need a remainder for some of the stuff we do, particularly if it asks for a remainder, like when we're changing improper fractions to mixed numbers and stuff like that. Otherwise, we can add. Now, and then we get to this point, we subtract and we get 0 here, but then 2 5/10 doesn't really look like money, right?
Yeah.
So sometimes you get a question that says, how much was this? And you end up with something like this.
You add a 0.
It just confuses your teacher.
And
Because in money, you're going to have
0.
dollars, so that's going to be before the decimal point.
Yeah.
Ones, tens, hundreds. You're going to have, let's say, dimes, quarters, whatever. So that's going to be in the tenths place. So we have 5 tenths here.
Yeah.
And nobody says, hey, that's 2 5/10, please. And then you guys would go to the store and you'd look at them. I don't understand how I buy Mr. McMurdo a Dr. Pepper if they're asking for 2 5/10. I don't know what that means. But it's the same. Is you just add the 0 after that because it doesn't change. That's 2 ones, 5 tenths, and 0 hundredths.
Yes.
I could put another 0 thousandths,
Yeah.
0 10,000. I could go on for ever if I wanted to, if I knew the place names of those. Okay, if I knew the names of the places of those. Cheyenne, you had your hand up.
Can remainders be in fractions? Or
Can
decimals?
Or decimals? No.
Oh, okay.
And we'll talk about, you're not going to see a whole lot. We're not going to have remainders and fractions. Let me show you why. Because, let's just say, okay, we have this. We just did this. We have 2 5/10. How would I write this? I mean, obviously my whole number, my ones, is going to be 2, right? Because my fraction is the parts. So Cam, I want to write this as a mixed number. So how should I do my fraction part?
5 tenths.
5/10. the cool thing about changing from decimals to fractions is really you say it the same way. 2 and 5/10. 2 and 5/10. Anybody have an idea what 5/10 might equal if I wanted to write it in a different way? Like something, no, Cam?
2.5.
Okay, 2.5. But how can I write 2 and 5/10 as something that's equivalent to it?
Oh my God.
Matthew, not Matthew B.
So 15 over 10.
15 over 10, it's not gonna exactly work. That gives us an improper fraction. Cam?
50.
I want to write this as 2 and something. What did we say? Let me ask this question and see if maybe it makes some sense. Matthew B. We said this fraction 6/12 equals what? Why does 6/12 equal 1/2? Because 6 is half of 12. So what do we notice about the fraction 5/10? 5 is half of 10. So I could make this as 2 and 1/2. Okay, now I can prove that. Let's see. I have my 1/2, and you're going to get some pieces like this so that you're going to do it. And I have my, let's see, I'm looking for 5/10 here. There's a way down there. There's a lot of tenths. Okay, so I got 1, 2, 3, 4, 5. Okay, so I can change my 5/10. Drop the tenth, 2, 3, 4, 5. So this helps me see that they're equivalent. It's like one of those activities, that one where you use the blue construction paper, knowing that you can write fractions in different ways. Like, let's just say, for example, I had to take, and let's say I had the fraction 3/8. And as, I don't remember who it was, probably Andres, told me if I said 2/8 plus 3/8 equals what, Andre? 5/8. So that tells me we only add the numerators, right? We only add the numerators. So one of our fractions equals 3/4. So let's go over here. 1, 2, 3. Now, I have some bigger ones that are foam, but they're stuck in the filing cabinet drawer that is
The baby.
with a baby in it, which I can't get open.
Oh, who did
So now all these people at home are like, what? Wait, what?
Show them.
He's got
Show
a
them.
baby? No, you can't show him because we can't get the baby out.
Oh, right.
We put baby in a corner.
Then just show it. Then
All right, so, okay.
He stuffed the head in his drawer and he can't get it out.
Yeah, I was trying to crush the baby's head.
And I tried to
So
cut
now,
off its leg.
all of these people that are watching in India right now are like,
I cut off
wait
the
a minute.
legs.
he's trying to crush the baby's head.
The baby doll. It's a small and tiny.
All right, so sit down, girls. Sit down.
I'm sorry.
Sit down. Sit down. Sit down. We'll look at the crushed baby in a little bit. We'll look at the crushed baby in a little
I
bit.
cut off the legs. Because
I never really thought I would say that in a math class. We'll look at the crushed baby in a little bit. So, in their Santa uniform, Sophia swam 3/4 of a lap. And we said that Jackson swam 1/2 of a lap. So Jackson swam
Daniel.
this much. And then we said that Daniel swam 3/8 of a lap.
And then there's Alexander. We
Okay.
don't know what he did.
So now I need to do some thinking. I need to decide that I'm going to think, even though I'm looking at it and I'm saying, doesn't make any sense. I can't do it. It doesn't understand. Even though the paper was like upside down and it was the blank side. Not only was it upside down, it was upside down this way. So even if you did turn it over, the print would be upside down.
What?
Don't decide immediately when it lands on your desk that you don't get it. Okay. So now, we have, let's see, we have, what's his name here, swimming a half, and then we have somebody swimming 3/4 of a lap, and we have somebody swimming
Jackson, Sophia.
3/8 of a lap. So let me ask
Sophia
you,
and Daniel.
how far did they swim all together? Anybody remember? Maya?
2 laps.
They had to swim 2 laps all together. So they needed to swim, that's 1 lap. Let's see.
Get 3.
And if I use this, 3/3 is equal to 1, right? 5/5 is equal to 1, 17/7 is equal to 1, or 17/17 is equal to 1.
Yes.
As long as the numerator and denominator are the same. So they needed to swim a total distance of this, because that is 2 laps. Even though they're wearing Santa suits, and there's a 73% chance that they are going to sink and die. I'm just saying Santa suits, especially if you have the pillow belly, it's just going to suck in the water.
It's a giant.
All right, so they needed to swim exactly 2 laps. So now we have this gap right here, is what we have to figure out.
About
And
a
that's
third.
But
That's all.
let's talk about this a little bit. All right, looking at this, I want some people to give me some observations of just looking at that. So what do we think? Just looking at that. Marilyn, okay, there's a gap I need to fill in. Okay, so this space right here,
And it's exactly the size of the.
okay, so this space right here
That's gonna be
is going to be how far that Alexander swam. So this space right here is how far Alexander swam. What are some other observations about what I have set up here? Angela, is that a hand up? Okay, here's fixing your hair. What are some other observations? Let's see. I have heard from a lot. An observation isn't, tell me an answer that's exactly right. No, what do you notice about it? You have to look at it. You can look at it and notice something, even if it's something ridiculous like they're different colors. Don't tell me that, because I just gave you that observation, so don't tell me that.
That 1/8 and that 1/3.
Red.
So Evelyn,
Go. She wants me to say this, but the 1/8 and the 1/3 is upside down.
okay, 1/8 and 1/3 is upside down.
Is
But you know why? Because I'm lazy.
and you're triggering.
So am I.
You're so triggering.
Because I'm so lazy.
We're buddies.
All right, what else do we notice about this, Lillian?
I was thinking to myself, that 1/2 was half. That half was half the 1, and then I saw we put 2/4. That was another half.
Good. So 1/2 is half of 1. That makes sense. 1/2 is half of 1.
Yeah.
But she also noticed that 2/4 is also half of 1. And if we look at that, 2 is half of 4, so that makes it a half. Okay? So I know these two right here equal exactly 1. So now I have these two left here. Okay, I have these two left. I need to make them equal exactly 1. So I have 1/4 and 3/8. So if I had to do this, okay, let's look at what we have here. First, what we have here is we have 1/2 plus 2/4 is going to equal what? 1 whole. I proved that right here. 1/2 plus 2/4 equals 1 whole. What do I have here is I have 1/4 plus 3/8 plus something I need is going to equal 1.
Yes.
And I know you can do this. You want to know why I know you can do this? Because my 8-year-old daughter was on Prodigy last night and she had to do something like that. Now it was only whole numbers, but you're not 8, so I'm thinking that maybe you can do better. Alright, so I need to figure out this gap right there. Need to figure out this gap right there. So Maya, what can you tell me?
This is 3/8.
And how do you know it's 3/8?
It's the same like with the 3/8.
Alright, well let's look and see if it's 3/8. let's look and see if it is 3/8. All right. So 1/4 plus 3/8 plus 3/8 equals 1. 1/4 plus 3/8 plus 3/8 equals 1.
Oh.
Matthew, what else do you notice here?
There's 3 numbers. There's 3 fractions.
Okay, we have 3 fractions here. Anybody else? Hunter?
Could be 6/8 plus 1/4.
Okay, so we have, if we do these two together, and we know we can add these two together because they have the same what? Say denominator, Marilyn. Say denominator. Good. We know we can add these two together because they have the same denominator. So these two, however, don't, but I need 1/4 plus 6/8 to equal 1. How many eighths would you need to equal 1?
2.
Okay, but if I just said, how many eighths are in one whole? 8/8, right? So I need this plus this to equal 8/8. This plus this to equal 8/8. Well, I have 6/8 here. So 6/8 plus 1/4. So how can I also say 1/4 in a different way? In a different way. Matthew, at the bottom of the alphabet.
2/8.
2/8.
Yeah.
So if I change 1/4 to 2/8 plus 6/8, that's going to equal 8/8, and 8/8 equals 1. So Matthew, let me ask this. Are you telling me that 1/4 equals 2/8?
Yes.
That's what Matthew's telling me. Can you believe it? That's cray cray.
I know.
Well, let's check, Matthew. Matthew's saying 1/4 is equivalent to 2/8. And if we look at that, boom, shakalaka, it works. 1/4 is equivalent to 2/8. All right, Matthew. Let's see what. So we want them. Okay, let me ask you this. So 1 whole. You said this 1 whole equals what? 8/8. Okay. 8/8. So this 1 whole will equal 8/8. So I need to figure out, I need to be able to change these to 8s, right? Because I gotta have the same denominator. I can't just say, my answer here is 3/6, because 3/6 is the same as 1/2, and 1/2, you can't add a half to something else and get 3/6. So what do you think that how many eighths would be in 1/2? Anybody have any idea? How many eighths are in 1/2? Marilyn?
I don't know that thing.
I don't know right now. So 1/2. Well, we do know though. If we think about that, I need how many eighths to equal 1/2? And what did we say when we started this? I need how many eighths to equal 1/2?
4.
The numerator has to be half of the denominator, right? So what I'm saying here is I need 4/8. I need 4/8. So I know 1/2 equals 4/8. And since 2/4 is exactly what? 2/4 is the same as 4/8. It's also the same as 1/2. So I can change this to 4/8. Remembering what a half is and how to find a half is really, really good. Knowing that you can use these and find equivalent denominators is good. Knowing that a fraction equals 1 if the numerator and denominator are the same. That's like saying that you have 8 out of 8 pieces. Okay? Your sister gives you, well, she didn't give you took it from her. Way to go, Laria. Man, you are a troublemaker. Okay, your sister gives you 1 bag of candy.
Thank you.
It has 8 pieces of candy in it. So if she eats 8 out of the 8 pieces, she ate a bag of candy. That's one whole. One whole is not always the same. One whole is not always the same. Because 8/8 equals a whole. But then Mayar's sister, who gave it to her because she was threatened to be beat up, had a bag that had 10 pieces of candy in it.
I want this.
Mayar ate 10 out of the 10 pieces, so she ate 1 bag of candy. She ate 1 bag of candy. They had a different number of pieces in it. One whole is 1 whole school year, or 1 whole year, 365 days. So if you're alive, 365 out of the 365 days, you lived 1 year. 1 year. If you ate 1 dozen eggs, how many's in a dozen? I always forget. 12, good. See, that's a question, you guys are smarter than a lot of the bozos I've had. Because that's a question that I ask sometimes, and they're like, or I give a question, she ate a dozen eggs. And they'll be like, I don't know what a dozen means. You guys are smart. Smart, that's what I'm saying. So, if you ate a whole carton of eggs, a whole dozen of eggs, 12 out of 12 equals 1. And I saw in Rocky one time where they ate the eggs raw. Alright, so, but that points out that not one whole doesn't equal the same, no matter what it is. If I eat 1 whole pizza, and I let the Matthew towards the top of the alphabet eat 1 whole pizza, well, maybe he's eating a large pizza, but he'll eat 1 pizza, and maybe I'm eating a small pizza, but I ate 1 pizza. He ate a whole pizza, I ate a whole pizza. So, it's the ones, something that equals 1 isn't necessarily, not all 1s are the same size. Not all 1s are the same size, not all 1s are the same value. I'm going to give you a chance to do some investigating on that after we get back from Coke Kerr in a few minutes. Boom! Shakalaka, peace out, God bless, love you, do something kind today.